Okay, we're going to talk about the linear parent function. So just remember to create or get the equation for a line in your calculator, stat enter, you stat over, and you're going to pick option 4. And then you should see y equals ax plus b, where a is your slope value and b is your y-intercept. So what we're going to do is we are going to get our calculators. I'm going to clear the memory. And we're now going to type in the equation into y equals. The linear parent function is simply y equals x. So I'm going to type in x, and then I'm going to go to my table, and I'm going to start filling in. And if you notice, your y values and your x values match. So that is why y value is equal to the x value. They are the same. So that should make it pretty easy to fill in our table because our x values and y values match. And so now we're going to go ahead and plot our ordered pairs. And again, your x value and your y values match. So that makes it pretty easy to plot your ordered pairs. And if you notice, it makes a diagonal line across your coordinate plane. And so now we're going to fill in the x-intercept. So I'm going to actually graph this, and I'm going to actually use my calculator to figure these things out. So I'm going to do second trace. Option 1 is going to fill in your y-intercept box. And remember, we always type in 0 for the y-intercept, x equals 0. And so my y-intercept is also 0, so it's the origin. And my x-intercept, second trace, option 2. And I want to go to my x-intercept. Well, my cursor happens to be right on it, but if not, I would move left or right until my cursor is on the x-intercept spot. So now I'm going to go left twice, enter, right 4 times, enter, and then enter to guess. And my x-intercept is also 0, 0 at the origin. And now I'm going to find my slope. Now there's several places you can look, but I always go back to the equation. Your slope value is going to be that imaginary 1 that is the coefficient of x. So your slope is a positive 1. And if you turn that into a fraction, it would be 1 over 1, which tells you you move up 1, right 1 to get from one point to the next in your picture for your graph. And 0 is the same thing as the x-intercept. So your 0 is actually x equals 0. Okay. Now we're going to talk about your transformations, and it's the same as we talked about for quadratics. So you've got IHOD, inside number, horizontal movement, opposite, which means if you see a negative subtraction sign, it's telling you you're moving right. If you see a plus sign, it's telling you you're moving left. And domain has to do with x values. Outside, it would be the number being added or subtracted outside of parentheses, so it has to do with vertical movement. And if you see an addition sign, you're moving exactly like you think you would up. And if you see a subtraction sign, you're moving exactly like you think down. And this has to do with range. So we've got translations, and this is actually, you've got your IHOD number. Okay, and if it's a positive number, this is going to move you left. And if you have a negative number inside the parentheses, then it's going to move you right. I'm going to say left shift and right shift. Okay, you also have a translation for your over. So this would be the number outside your parentheses. I'm using that hashtag for your number. So if you have plus a number, it's going to move a shift up. If you have a subtraction sign outside your parentheses, it's going to be a shift down. And then obviously how many, that number is going to tell you how many you're shifting up or down. Okay, for dilations, you don't really have a dilation. What you have is you have your A value. So if your A value gets bigger, okay, and your A value is going to be that number that is in front of your parentheses, okay? It's your A coefficient, the coefficient on your X, okay? If your A value is getting bigger, your line is going to be more steep, okay? Think about a hill. If it's steep, it's getting closer to being vertical, okay? If your A value gets smaller, then it's going to be less steep than the original line. You can also think of that as getting flatter. Okay? And reflections, this has to do with your A value. If you have a positive A, there is no reflection. And this tells you, if you remember about your A value, it tells you that your line is going to be slanted up. If you have a negative A, that's going to cause your line to slope down. Okay, so slant down. Whereas if it's a positive A, it's going to slant up. Okay. So you can think of your A value as kind of like your slope value, okay? It's going to tell you if your line's getting steeper, slanting up, depending on its sign, or slanting down, or it's going to get flatter if your slope is small, okay? So now we're going to look at some examples. So we've got this value here, and here's how we're going to write this one. We're going to write it like this. So I'm going to say 3x minus 2, and this is my start. So this is my before, and this is my after. So the G graph is always our after. So if we look at our before, we started at an A value of 1, and then we went to an A value of 3. So 1 to 3 would be A getting bigger, so that's telling me that my line is going to be more steep. And now I'm going to look at, do I have any inside numbers in the parentheses? And no, you do not. But I do have a number outside the parentheses, this -2. So the over outside, it's going to tell me if it's moving up or down, and it's going to do exactly what I think. So that -2 is telling me that it's going to move exactly like I would think, and that would be down 2. Now, we're going to go to our calculator, and we're going to go to y equals, and we're going to type in both. So I'm going to type in my before, and then I'm going to type in my after equation, and I'm going to change that to the thicker line, and then I'm going to graph, and I'm going to see, does the after line get more steep and move down 2? So let's look. So it looks like it moved down, and then you notice how it goes up faster than the other one, so it would be a steeper hill to climb than the other one. So yes, it did get more steep, so that is correct. So now we're going to look at example 2, and again, we're going to change this G graph. We're going to say negative parentheses x plus 2. So now I'm going to look at my A value. So it was 1 here, and here it's a -1. So it went from 1 to a -1. So it's telling me that it's going to slant down. That would also be a reflection over the x-axis. Okay, slant down. I'm going to put over here with slant down, reflects over x-axis, because they may say that instead of slanting down. And then slants down, we should add reflects over x-axis, reflects over x-axis. And then we're going to look at, we have an inside number, parentheses, plus 2. Because it's an inside number, it's going to do the opposite of what we think. So subtraction means right, addition means left. So we have addition 2, so plus 2. So we normally think that moves right, but because it's doing the opposite, it's actually moving left 2 units. Okay, well now let's go to our calculator, let's verify. So we're going to clear this out, we're going to leave it as x. If you type in 1x, that's okay. And we're going to type in negative parentheses x plus 2. So we should see our second after line slant down, or reflect over the x-axis, and we should see it move left too. So let's graph. There's our original, and it does, if you look at the y-intercept, it does, or the x, it does move too, and it does slant downward. So that does look like it's doing what it's supposed to do. All right, and we're not going to worry about example 3, okay? So now hopefully you can pick out transformations. Remember, put both equations in your calculator and compare what you are seeing to the description or matching it up to the numbers based on what it's doing.